Hi everyone, myself Fepsin Adishman. I am working as an assistant professor in Computer Science Engineering Department. Here we are going to discuss some topics in computer organization and architecture. Next we are going to see about microprogram sequencer. So microprogram sequencer is a control unit which does the task of the microprogram sequencing. So we have to consider two important factors in the case of design of microprogram sequencing. One is size of the micro instruction, another one is address generation time. How much time is required to generate an address? These two factors we have to consider. And if you are taking a typical microprogram sequencer, it should have the 5 capabilities. That is, it should increment the present address of the control memory. Control memory is a current executing location. So we have to increment that to the next location. Then we have to do two types of branchings. There is one is within the micro instruction itself. That is, we have to do some small branching inside the micro instruction itself. Otherwise, in some cases, we have to do a branching with the specific to the comparison or some status bit values. That is, so if you in some cases, if this is greater than 1, you have to go for this, or if this is bigger, we have to do this operation. Like this, some branching is happening. There is depends on the status bit of the instructions. Then the next one is transfer control to a new address as specified by the external source. In some cases, we have to move the control to the external sources. That is another one type. Another one capability. Then have a facility for the subroutines, calls and returns. That is, a microprogram sequencer should have a capacity to perform subroutine calls and returns. So the detailed block diagram is given here. The core part of this is control address register. So control address register is just like a PC counter register. This holds the address of the next micro instruction to be executed. And just like PC counter, it is also incremented automatically. And the MUX is connected directly to the control address register, and this MUX is responsible for giving the corresponding line to the control address register. Okay, so here this will give the corresponding line. For example, if you want to give an external address, this will connect the control address register will get an external address from the MUX, or if it requires a branch address, this MUX will provide branch address to the CAR, that is a control address register. And if this requires an auto increment, that is next instruction, if it is required, it will be given through the incrementer, and like this control address register will perform, and this will finally provide the output address to the control word memory or control memory. Okay, that address location will be fetched and executed. Okay, and along with this, we are having stack register to perform stack operations. That is, in case of subroutines or some branching, we need to perform stack operation. For that, we have a stack register, and to assist the stack register, we need a stack pointer. So all these things are controlled with the timing lines and the external control inputs. Okay. So that's all regarding the architecture of microprogram sequencer. Thank you.